topic. All right. So we got arc length and surface area. Test is on Thursday, yes.
No.
Yeah, I have a test next Thursday. You should move it.
I'll be happy to do the test on Wednesday. It just cuts out a review day.
That's fine.
Ethan,
That's
What are we gonna do Friday?
We should just all watch.
Friday, you don't have your assignment for the break.
What?
So you can get pissed at me now, or you can wait till next Friday.
How long is the assignment?
Not long.
Not long.
Oh, is it just like a worksheet? Yeah, some of my teachers are remote.
It's a worksheet for every day.
Well, it's a packet, but if you're in class, you'll probably finish half of it. If you don't come on Friday,
Is it
then
a review packet or like a?
anything new.
Okay.
It'll be a practice packet to kind of keep your skills up.
Okay.
It's not horrible. Maybe I'll be nice and count it as extra credit or something. Who knows?
Well, Christmas starts tomorrow.
Okay.
Wait.
All right. These are our last formulas: arc length and surface area. Okay. So we'll go through the setups here. You've already discovered that half the problem's getting it in your calculator sometimes.
Yeah.
Exactly. So we'll go through the different setups. That way, it gives you a little more time with your homework to work on getting it in the calculator. Then next week, when we're reviewing, we have area, which was easier than volume, I think. Then volume, and then these. Okay. Now, arc length. Arc length, we're just referring to how long the curve is. It's whatever the length of the curve. Right. Surface area would refer to, say you're going to rotate that guy around an axis. Well, instead of the volume of the inside, it's the area of the surface on the outside.
Okay.
That's what it's talking about. Does that make sense?
I think so.
Right.
Sure.
Okay. We'll do arc length first, but one of the things to notice on the surface area formula, look what shows up in there.
All right.
That's your arc length, right?
Oh, I was looking at the wrong part.
And
Yeah.
that's the radius. So it's taking the arc, this length, and then rotating it around. That's what it's working with. So usually if you can remember this, you're pretty good down here. Okay. Now the only difference between this and this is if we have a function in terms of y. We have y limits, function in terms of x, which most of them are, x limits.
Okay.
That's all it's referring to, okay?
So is that an F prime? So
That's an F prime.
Okay, so that's the derivative.
The derivative. We're going to have the derivative inside.
No, this is good.
So,
This is good. This is good.
now let's say arc length for f of x equals x to the 3/2 from 1,1 to 927. So for our arc length, and they just use a lowercase s for the arc length. Integral, we have x's. So sometimes we're given ordered pairs like this. Sometimes we're given an interval, but it would be 1 to 9. We have x's. We need x limits. Change in there. We're used to seeing that. Square root 1 plus now our derivative. So there's nothing new on the derivative. We know how to take a derivative. So the derivative of this would be 3/2 x to the 1/2 squared dx. Now it really depends on your calculators. Okay. For me, I don't have like the math type or whatever on my calculator, so I'd have to use a lot of parentheses. So for me, I would much rather simplify this when I can. Okay. But it really just depends on you and your calculator. So for me, I'd make this 1 plus 9x over 4 because I could square that out.
Okay.
Okay. But again, that really depends on how some of your calculators are working. If I had one of those newer ones with the math print on there, I'd probably leave it like this, but It kind of depends on what you've got. Okay. So let's try to get this one entered. You should get 27.3. So let's make sure we get this one, and then we'll just set up the others. Again, by now you kind of know what works really well in your calculator and what struggles as far as entering them. Does that work in 27.3?
Yeah.
Yeah.
So if I wrote it like this, arc length of y equals x squared plus x minus 2 on -2 to 1. Now you're given an interval. The interval is referring to the x's. So s would be integral of -2 to 1, square root of 1 plus 2x plus 1 squared dx. So if the derivative's easy, it's a pretty quick setup. There's not much going on to it. All right? If you get something that's a more complicated derivative, then the setup might take a little bit more, but there won't be anything new as far as taking a derivative. On surface area, let's do this. C3. Surface area. Functions f of x, x cubed over 2, and 0 to 2, my interval. And we're going to say about x-axis. So our formula again, here's this arc length in here. So we're basically taking the length of the arc and then going to be rotating it around to create a three-dimensional object. That's what we're finding the surface area of. Right? This front piece is the key. 2 pi is our rotation. It's taking us all the way around. This is referring to the radius. So if I am going around the x-axis, the radius would be the function. Now, just to kind of make up a graph here, if this is the x-axis, here's my function. Well, if I'm going around the x-axis, well, the radius is how far the function is away. That's why it's the function. Does that make sense? Now, if I was going to go around y equals -1, it'd be the function minus -1. So similar to that shell method. So we'll get a couple setups here. X-axis, we're going to have 2 pi, 0 to 2. My function, x cubed over 2. And what I want you to do to start with is put that -0, because that'll remind you it was the x-axis. Right? We've talked about this before. You don't need it. Book doesn't show it, but it does happen sometimes. It can change from a 0. Right? So in the beginning, it's good to have it there. Now here comes the arc length. Square root 1 plus 3x squared over 2 squared dx. Now most everything for surface area is going to revolve around an axis. X-axis or y-axis. And the reason is if we're talking about some object we're creating a surface area of, like say a bottle or something, well you can make it where the axis is going through the middle of the bottle and there's your shape you're rotating. Okay? But it could go around a different axis. So if I said about y equals -2, then this part right here is what changes. X cubed over 2 minus -2. Everything else is the same. Now, what if I said y equals 20? Would it be the function minus 20 or 20 minus the function?
20 minus
20, because that function right there, 20 is sitting up above. Okay, so still that same idea.
I was just gonna ask, if you do like what you're talking about right now, does that account for the surface area of the inside? If you have like a hole on the inside?
Well, it wouldn't be a hole, you just made the function bigger. You just made it bigger around,
Oh, okay, yeah.
right? So if my axis was here, and you're rotating it this way, now if I move the axis here and the function here, you just made a bigger one. So it made that larger surface area. So basically it's adding 2 to every one of those radiuses there was. Is everybody okay there? So that's pretty similar. If we're going about the y-axis, s 2 pi integral 0 to 2, out front here is x minus 0. And then here comes my arc length. Now over here, the way it's written in your book, it just shows r of x because it's referring to the radius, how far you are away. So I wrote for you, only x is about y-axis. Technically, it's not only x, it's really x minus 0. And again, think about it. If your function's over here somewhere, and we're going to go about this guy here, how far is each point from the y-axis? X units. X units from the y-axis. It's y units from the x-axis, but y is the function. It's x units from the y-axis. Does that make sense? So if I was going to go around instead of the y-axis, if I was going to go around x equals negative 3, you'd have x minus negative 3. Same idea as what you had in the shell. Right? A lot of times we get confused because we wonder, well, how come it's just x going around the y, but it's not y going around the x? It is y. Y equals x cubed over 2. That is the y value. That piece. Are they okay with that? And again, you can tell probably the worst part's entering it in the calculator.